Thank you for joining me for this rather unique experience. I'm in the NDC DevOps conference venue and I'm staring at an empty room. So we all appreciate that the last 24 hours has been quite a challenging experience. So I just want to take a quick minute just to say thank you so much to the NDC team for doing an amazing job at switching this conference to a fully virtual event. The AV team here have been amazing as well. And of course, you folks at home who are joining us remotely now. Thank you so much. So with that, let's crack on. So we'll be doing Q&A using Slido. So you can see the details there. I've also got the details on the bottom of every slide, and I've got the Slido window available to me as well. So please do go and ask questions as we go along, and I'll try and answer as much as I can. So what we're going to talk about today. So I want to talk about how we provision cloud infrastructure. Well, actually, general infrastructure in general. I want to talk about some of the limitations we have with that approach we use. And then I want to talk about a tool that I found extremely helpful called Pulumi. So a couple of caveats. I'm going to focus on Azure and .NET, but the principles I'm talking about apply to everything. So it doesn't matter what platform you're using, and it doesn't matter what language. Most of what I talk about is applicable. So this talk is inspired by some of the work I do with smaller clients who have to deal with cloud infrastructure. And I did want to also specify that I don't work for Pulumi. I'm in no way incentivized by Pulumi, so this is not a sales pitch. So who am I? Well, I'm a freelance Azure consultant. I specialize in Azure, Kubernetes, and cloud-native technologies. So over the decade, I've been mostly a .NET developer. I also dabble in some other languages. I'm an MVP, and I also co-organize the meetup in the UK, so miltonkeynes.net. Main reason really for this slide is my contact details. Oops, apologies, let's go back. As I said, I'll try and answer questions on Slido as we go along, and please do ask questions on there. If I don't get a chance to answer your question, or you just didn't want to ask it on Slido, do feel free to get in touch with me. So when we think about provisioning infrastructure, particularly in the cloud, the first option that most people start with is they turn to the portals. And the portals are a great way to get started provisioning resources for a number of reasons. Firstly, they're discoverable. So you can figure out what resources and what options and services that your cloud provider has by visiting the portal. They also give you wizards that allow you to start creating these resources in a very clean, stepwise manner. And because they have options within those wizards, you can also ensure that you pick the right options. They can filter drop-down lists, and they can make sure that you are creating the resource exactly the way you want without ever selecting anything invalid. And the other reason portals are great is because some people are generally more comfortable with GUIs. Now, I tend to like the command line, but there's nothing wrong with people who like to prefer to use the GUIs. Now, there's a few challenges with the portal. The first one being that it's not easy to repeat what you did consistently. So we as humans are terrible at repeating things, especially boring, mundane tasks. Sometimes options you want in the portal can be buried 2 or 3 layers deep in submenus. And you have to click through all of those to get to those options. Also, if you want to provision multiple resources, things can be tricky there because there's only one of you doing the clicking. Maybe if you're ambidextrous, get yourself a couple of mice and try and do 2 deployments in parallel. But that's about the best you're going to manage. And also, you have to figure out the dependency tree. So if let's say you're deploying a website, you probably need to deploy a storage account first. So you probably need to go and deploy that first and then deploy your website. So it's with these challenges in mind that we've come across this term infrastructure as code in the last few years in particular. And essentially what this says is that rather than manually or interactively deploying resources, we use some kind of definition file. And of course, the first port of call for these is usually the cloud providers. So we have the Azure Resource Manager, we have the AWS CloudFormation, and we have Google Deployment Manager. And of course, I'm sure the cloud provider you use will have the same. And again, various private cloud offerings also have exactly the same types of options. So let's take a look at a Azure Resource Manager template. Now that text is very small, but don't worry, we'll dive in a bit closer. I just wanted to get a feel for the size of the template. So let's take a look at this a bit closer. So here we are, we're setting up some parameters. The first option, we're setting up a storage account type as a parameter. We're saying it's a string, and we're giving it a default value. And notice the default value is a very precise string, because when we are using these templates, we don't have the benefit of the UI giving us drop-down lists. So instead, we have to ensure that people who are using our template can only select valid values. So we can do that, and we can see that we can also provide a list of other options that people can use. Now, as a template author, you need to ensure that you are using the correct strings there. You need to ensure that you've checked with the cloud provider, and also if they add any new options, you need to ensure they're available in your now out-of-date list. Okay, so that's one parameter. Let's take a look at another one. So here we're defining another string parameter for the location, and we're setting a default value of something called a resource group, and we're taking the location from that. Now, if you haven't noticed already, this template was essentially a JSON file. But when we look at that default value line, what we're seeing there isn't what we normally see in JSON files. We're seeing what looks like a function. And that's the first clue, really, to where some of the challenges lie in using these templating languages. Okay, so we've got our parameters. We can also create variables. So here what we're doing is we're concatenating a string called store with another string that we're deriving from some kind of function of an ID. But again, we're now starting to see these unique languages, syntax that we're seeing that's built into what is essentially a string value. Once we have that, we can now go ahead and provision our resources. So here we're creating a storage account, and you'll notice that what we're doing is we're taking those variables for the storage account name, and we're taking the location, and we're also adding that the SKU, we're picking the value that somebody would have chosen from that drop-down list. Or well, it's not a drop-down list, but a list of options. And also, once we've created this, we can also output certain values, because what we want to do is potentially pass values from provisioned resources into other tools in our tool chain. So once we have this template, what we can do is we can now go and execute. We have a number of options here, but in this example, we're going to use the Azure CLI, and we're going to do AZ group deployment create, and we're going to pass in the template. And the nice thing with this line is this is automatable. There's nothing special in this line. Everything we need to create the resource is described within the template file. So that's great. So we look at some of these pros. We can automate these, and that's precisely what we want, because automation will give us consistency, and of course it stops the human having to do the boring things. There can be idempotent. So what this means is when we deploy the resource once, if we don't change anything and we deploy it a second time, nothing changes. We don't create a second instance of everything. They're declarative. So you notice in that markup file, we described the state we wanted. We didn't describe how we achieved the state. We didn't say, first make this, then make this, then make this, and join them together. We just said, I want this. And that's exactly what you want, because the underlying mechanism of how those things are created can change, and you don't care. And of course, as you've seen now, it's very easy to recreate multiple resources, because we have the template, and we can execute that with different parameters every time, and we get more and more resources. And largely, the resource dependency is resolved for us. So we've told Azure Resource Manager we want a storage account and maybe some other things, and it will figure out that we need to create the dependencies first and then the storage account. There are some downsides to cloud templating, and we'll spend a bit longer on these in a few minutes as well. First thing is they're verbose. You saw that for creating essentially a single resource, we had a whole page of JSON. You also saw that even though it was JSON, there was some very domain-specific syntax in there. So we'd have to learn this particular syntax. Now, if we're only using one cloud provider, maybe that's acceptable. If you're using multiple cloud providers, that may not be such a great option. Of course, if it's not something you do day in, day out, then remembering that syntax may also be a challenge. The other issue is that the Azure Resource Manager is closed source. If you wanted to implement some specific functionality, you can't just contribute a patch or something. So try and tackle some of these issues. People often turn to a tool typically Terraform is one of the most well-known tools. So Terraform was created by HashiCorp, and it uses its own markup language called HCL. The key difference with Terraform is you can use the same language, the same syntax, but target multiple clouds or multiple platforms. It's open source, so if you want to modify or add additional functionality, you can submit a pull request, and hopefully that gets merged in, and you have the new functionality. It's written in Go, which is a modern cloud native language that lots of people are turning to, so the performance is pretty good as well. Of course, it depends on the underlying cloud provider as to whether you get exactly what you expect. So let's take a look at a Terraform template. Here we're looking at Terraform template, which is creating a resource group and then a storage account. And what we can see is we are referencing that resource group we created earlier, and we are pulling out the name and the location from that. So we're saying resource group .example.name and .example.location. So this allows us to create a nice template which will have the dependencies referenced, similar to what we had with ARM templates as well. So there are some downsides with Terraform. So again, it's another special language, and it's a language that only works with Terraform. As I said, Terraform is better in the sense that you can, a lot of the syntax you learn, a lot of the functions, the special concatenation functions and everything else will now be applicable across multiple platforms. And of course, as you've seen, the template is more concise in my opinion. Terraform and many tools like Terraform will have a problem in the sense that they will always lag behind the cloud provider. So every time a new functionality or new feature is added to the cloud, there's inevitably going to be a degree of lag until that feature is implemented in the tool. Now, of course, being open source, if there's something you want desperately urgently, of course, open an issue, create a pull request, and hopefully you'll have that functionality as quick as you can write it. Terraform also has to deal with state. And state management can be an issue. In particular, if you're not careful, you can have sensitive information appearing in some state files which are stored outside of maybe your normal secrets management. What if you have more complex deployment scenarios? So typically, and I'll show an example of this later, we have to do things like conditional logic. So we have to deploy resources based on a parameter, for example. We may need to have loops. We may want to have numerous resources provisioned in a loop of some kind. And we may need to invoke third-party code. And all of these are possible with ARM templates and Terraform, but they introduce a syntax which is maybe not the most understandable. So let's take a look at an ARM template which is doing conditional logic. So here we've got a parameter called production, it's type string, and we've said it can be yes or no. And now we're deploying a website, and we're using a condition element. Sorry, I'll just click through that. Condition element, and we're saying if this condition, if the parameter production is equal to yes, then the condition is true and the resource will get deployed. Obviously, if that's not yes, then it won't get deployed. But if you look at this and you'll say, well, is that yes and no? Is that case sensitive? I'm not sure. If you work with ARM day in, day out, you'll know this off the back of your hand, and that's fantastic. But if you don't, then you have to go back and look at the documentation, remind yourself, and it's easy to make lots of mistakes like this. So let's take a look at the equivalent example using Terraform. So now Terraform's got a variable called isProd. It's a Boolean type. And now what we're doing is in our resource, we say if the Boolean is true, then it equates to 1, otherwise it's 0. So it's a ternary expression here. And that value is set as a count. So what's happening here is if it's not prod, we get back a 0, so the count is 0, and Terraform won't deploy the resource because the count is 0. So you can see this is admittedly a bit of a hack, really, but maybe it's a bit easier to understand. Let's have a look at loops. So we're back to ARM again. We have an array, and it says production or development. And now what we want to do is we want to loop over this array and we want to provision resources. So what we're doing here is we're collecting the name of the resource by concatenating my app with the array, and then we're indexing into the array based on the loop we're currently in. And then further down, we have a copy element, and we're essentially telling the resource manager to copy this resource n number of times, which is the length of the purpose array. I've been speaking for 2 days, and I have a bit of a cough, so please don't panic, everyone. And plus, you're many miles apart now, so we should be fine. Let's take a look at the equivalent, so how we do loops in Terraform. So now we have a variable. It's of type list, and we have dev, staging, and prod. So now what we're doing is we're doing a count again, and we're doing the length of the array, and we're just picking the name out from the index of that array. So as I said, these things are achievable in Terraform and ARM, but if you don't work with Terraform and ARM on a daily basis, they are not the easiest things to understand. So we come back to that statement about infrastructure as code. And one word stands out to me more than any other, which is code. So I'm a developer. This talk is pretty biased towards developer perspective, in my opinion. And when I look at code, I expect to see modern programming languages. I expect to see constructs that I'm familiar with, conditional blocks, loops, Boolean statements, that are recognizable. What I really see is ARM and the equivalent in Terraform and in CloudFormation and Google is essentially markup languages which have had these programming constructs shoehorned into them. So instead of infrastructure as code, what about infrastructure as software? So it's not a term, excuse me, it's not a term I've come up with, but it's a term that's starting to gain a bit of traction. So in particular, there's a tool that I've been starting to use called Pulumi. So Pulumi is an open source tool, and it's used for provisioning resources, and the key difference with Pulumi is it uses modern programming languages. So it supports many platforms, and although the code you will see looks like a declarative code, it's not. It is, it's exactly the same as the ARM templates. It's a desired state. So I said it's open source, it's free. There is one component within Pulumi which isn't free, but as I'll talk about later, this in no way hampers your usage of Pulumi if you want to get started with it. So Pulumi supports Node, Python, .NET Core, and Go at the moment. .NET Core and Go are currently in preview. I believe they're due to maybe go GA within about a month or so. Now the model is open, and we'll discuss the model in a few minutes. So if there's a language you like and you want to implement it, you can go ahead and implement that language to tie into Pulumi. In terms of platforms, Pulumi supports a number of platforms. You can see the main cloud providers are there. We can see some infrastructure providers. Compared to Terraform, Pulumi doesn't support anywhere near the same number of platforms. But there's a decent amount here, and once again, the model is open, much like Terraform is. So if you want to support a new platform, you can implement a provider yourself and have support. Now, I won't have time today to discuss it, but if you've followed my talks, you know that every other talk I've given at our conference has always mentioned Kubernetes in some way, form, or fashion. So you'll notice that one of the core providers here is Kubernetes. So just to tease you, imagine the concept of using Kubernetes and configuring Kubernetes without having to write a line of YAML. That sounds quite interesting, and it'll be something that I'll be looking into a lot more going forwards. So how do I get started with Pulumi? The first thing I need to do is I need to install the Pulumi CLI. It's cross-platform CLI, and you can just download that from the Pulumi website. If you're on Windows, I recommend using Chocolatey, and you can just do choco install Pulumi, and within a few seconds, you'll be up and running. So when I want to get started, what I can do is I can do Pulumi new and pass in the name of a template. So in this case, it's an Azure C# template. It's asking me for some parameters, and I can just accept the defaults. And after a few seconds, it's going to give me basically a .NET Core project, a C# .NET Core project. That's targeting Azure. So we can see there, tells me I'm ready to go. So let's take a look at this project it's just created. So here I am in Visual Studio Code. And you can see on the left-hand side, we've got a program.cs. We have a couple of YAML files, and then we have the CS proj. Just want to briefly show you the CS proj. So this is a .NET Core 3.1 application, and essentially it's a console application. You can see that there. It says output exe. And it has a NuGet package reference added, pulumi.azure. So that's all that is there. So let's dive into the code. There's been enough talking. So this is the program CS. And what we're looking at here is the entry point to the application. And what we can see, first of all, is we're creating a resource group. So we're doing new resource group, and that resource group object is coming from the Pulumi NuGet package. And we're passing in a string as the name of the resource. And we're creating a variable. So the next thing we're doing is we're creating a storage account. And again, we're newing up storage account. We're passing in a string as the storage account name. And then we're passing in these args. So this is a very common pattern in Pulumi. In .NET, you will create the object and you pass in an args object, which contains all of the options and parameters you want to set. So here what we're doing is we're setting the resource group name to be the name from the variable that we assigned earlier. So you notice that we assigned a variable called resource group, and we're now taking the name object out of there. We're setting the replication type and the account tier. So now I've written my code. In fact, that's the sample code that gets created as soon as you create a Pulumi new template. So what do I do now? So if you try and compile and run that code, it's just an XC. It won't do anything because essentially what's happening there is that code is being compiled into a resource graph, essentially, that helps Pulumi figure out what it needs to create. So we come back to the Pulumi command line tool, and we run Pulumi up. And what this will do is compile the code. And then after it's compiled it, it will tell us what it thinks it's going to do with this code. So what state is it going to create? So after a few seconds, we'll see that it's telling me I'm going to create a resource group and a storage account. Now I can preview what it's going to do, but in this case, I'm just going to go ahead and say yes. So now it's going to compile the code again. I think that's just to make sure that nobody has changed the code in the meantime. And now you can see it's going away and it's now creating these resources. So this is talking to my Azure subscription. You can configure this in a number of ways. On your local machine, it can pick up environment variables. If you're using this for any kind of CI/CD system, it can use a service principal account. So as I'm talking, we are now have the resource group created, and you can see the storage account's already created as well. And I've asked Pulumi to output the connection string from the storage account so that I can then use it for something else. Now don't worry, I know the secrets are visible on the screen, but the storage account doesn't exist anymore, so I'm not concerned. And all of that took 33 seconds. Okay, great, that was easy because we're just creating something. So let's take another look and let's make some changes here. So what I'm going to do is I'm going to add some tags. And what you notice is I'm getting IntelliSense here. So it tells me I can do some tags. So I'm going to add some tags of owner equals foo. Okay, so now I've added the tags. I can go back and run Pulumi up again. And let's see what's going to happen. Is it going to recreate everything? So once again, it's going to compile the code. And it's going to tell me that there's one resource to update. I can dive into the details of this. So if I go down to the details, it gives me much more information, and I can see that it's going to add some tags to this resource. So it's not going to recreate the resource, it's not going to delete anything, it's just going to add the missing elements. So I can go ahead now and do yes, confirm that I want to do the update, and Pulumi will go away and now do the update. And that will take a number of seconds, and there we are, so we're done. Now so far you haven't seen the resources it's created. So this could all be smoke and mirrors. So let's dive into the portal and take a closer look. So here I am in my resource group that Pulumi created, and there's the storage account. So just make that a bit clearer. So there we are. Now you'll notice that the resource group name has this string appended at the end, and so does the storage account name. So we said storage, well, storage account was called storage. So by default, Pulumi will append random strings to the end of resource names to prevent naming collisions. Now I know most of you out there, or certainly quite a few of you out there, normally have very strong naming conventions. So you're concerned about, well, how do I name my resource? Well, you still have that prefix available, so you can still put the naming convention in the prefix and just ignore the additional strings. You can override that behavior, and there are very few reasons why you would. So some examples might be a domain name. A domain name you probably don't want the random strings at the end of, especially if it's kind of client visible. But most other things, you shouldn't care about the name of the resource to that level. If you do, it's probably an indication that you are heading towards kind of the pets versus cattle problem. So once I've finished, so for example, I'm doing a test or I'm just checking this, what I can do is tear down my resources very simply. So I can run Pulumi destroy, and it will tell me it's going to delete everything. I can just go ahead and say yes, and then that will go and delete the resources. Now, you have to recognize that it's going to call the cloud provider, and that can take some time. Cloud providers are notoriously challenging in terms of the amount of time it takes for things to run. So in this example, that video, all the other videos you saw were not in any way cropped. This one was paused and it took 55 seconds. But now the resource is gone. So I can see a question from Oleg asking, is there any performance penalty in terms of deployment time when using Terraform or Pulumi instead of directly using ARM templates? I don't know exactly, to be honest. I suspect there's probably marginal differences in there. I haven't had a chance to compare them myself, but yeah, I suspect it's marginal. If you've got something that's very time consuming, it would be quite an interesting one to try. So thank you for that, Oleg. So let's have a look at the Pulumi components. So I talked about this language. You can write your own language. So there's a language host. The language host's job is to take the language you've written and essentially convert it into some kind of resource tree. And that gets passed to the CLI and actually the Pulumi engine. And that's really the brains of the operation. And what that does is that will then invoke your particular provider and essentially do CRUD operations on that. Now the state, much like Terraform, there's a state file created, and that state is stored in some backend store. So Pulumi has a number of options here. You can store it in a local disk on the local machine. You can store it in a cloud storage backend. Or Pulumi also have a console. So when I touched on the fact that I said Pulumi was free and open source, there's one component which isn't, which is this console. The console you are allowed to use as an individual, and we'll take a look at it in a second. You can use it in a company setting, but as an individual only, and you can have as many projects as you want. But if you want to use it as a team, you have to pay for that additionally. Unlike many projects that have a kind of commercial side to them, Pulumi doesn't in any way hamper or restrict the core functionality of the application. You can use the private backing stores and get the same behavior as you want without ever using Pulumi itself. One of the reasons why people don't necessarily want to use the Pulumi provided service is because your secrets may be sent up there. So Pulumi does encrypt all the secrets using a per stack encryption key, so they can be stored in source control if you wanted safely. But obviously some people don't prefer that. If you want to use Pulumi on an on-premise system, you can also get an on-premise version of the Pulumi system if you wanted. So let's take a look at that dashboard that I talked about, the Pulumi console. So this is the Pulumi console, and it's just me using it, so it's not costing me anything. And what I can see is I can see some stacks. So I've clicked through to one of the stacks, the one I've deployed earlier, because I have some other projects on there I didn't want to show everyone. So what I can see here is that when I ran it, I saw the resource group was created. I can see the details of that. And then I can click through and see the individual steps that were taken. So then I did the tag update, so I can see that, and then I can see that it was deleted. So if you're a small team and you have predominantly one person responsible for managing infrastructure, you can use this console for free, and it's a great way of keeping track of what's been going on in your infrastructure. So one of the other challenges I mentioned was about invoking third-party APIs. So using templates or Terraform, usually what you need to do in this situation is drop down into some kind of script inside the template. The challenge with this is you can't easily test that script. You often rely on third-party infrastructure to be available on the machine that you're running on. And often you have to write this in a different language. So you've now learned the syntax for the templating language, and now you have to switch to Bash or PowerShell. And again, people who do this day in, day out as their job, that may be absolutely fine. I'm really talking to people whose job isn't day in, day out to be managing the infrastructure. I mean, this is very applicable to everyone, but this is a special case that I've been finding this really powerful for. So let's give you a more concrete example. I was deploying an Azure storage account, and I wanted to enable the static hosting. The static hosting on Azure storage is a fantastic way of running websites, static websites, and spas, because you run it straight from a storage account, you don't have to pay for a web server, and it's fantastically cheap. One of the challenges, or the challenge with this particular feature, is that it can't be enabled through the Resource Manager API. That particular option is not surfaced for some reason. So what this means is ARM templates, no Terraform, no Pulumi out of the box, can actually enable this feature. So if you want to enable this feature, what you have to normally do is invoke some kind of script or CLI command. So fork out a process and call the Azure CLI and ask it to enable this feature. But I was thinking, well, I'm working in a .NET Core project, and I know there's a .NET Core storage SDK. So can I use that? So the example I'm about to show you is available at that link. It's part of the Pulumi examples, which has got a repository of quite a large number of examples across the different cloud providers. So let's take a look at what's going on here. So what we're seeing here is we're creating a resource group like before. We're creating a storage account like we did before. I've specified a couple of other things that I wanted to have in this particular storage account. But the interesting bit comes on the next page. So we're now doing this. Let's dive in a bit closer first. So what we're now doing is doing a deployment.instance.isDryRun. That deployment object is coming from the Pulumi environment. It's a static instance. And it's telling me if I'm running Pulumi, am I running Pulumi preview, which is a way of checking that your resources are going to be created as you expect, or I'm actually invoking this for real. And what I want to do is I only want to run this if it's a real deployment and not a dry run. And what I'm doing here is I'm taking the storage account, I'm taking the connection string more specifically, and I'm invoking a function, and I'm passing in the storage connection string. So we'll come back to this snippet in a second, but let's have a look at that method. So this method is now receiving that connection string, and it's using the Azure.NET Core SDKs, and it's creating a cloud storage account using the connection string. What we're doing now is creating a blob client, and we're basically setting up the static hosting feature. And so we're setting it enabled to true, we're giving it some values for the default documents, and we're updating our storage account. Once we have that, we come back to our main Pulumi code, and now we've got an array of files. So in this demo example, we've just hard-coded the list of files. The files are in this repository as well. And now we're for-eaching over those files using for-each code that every C# developer will know from day one. And we're creating a new blob. So this is another Pulumi resource object. And then we're setting the storage account name, and we're essentially copying the content into that blob. And what we can then do is output the resources. So when I go and deploy that, eventually it will tell me it's created my static site, it's created the blobs, and I get back a URL. I'm not showing it here, but it's giving me a URL, which lets me then access that static site. So if you want to have a look at that, you can go to the examples repo. I'll put the link up again towards the end for that. So I want to talk about, so far what I've shown you is reasonably trivial examples. So again, you could argue that the Pulumi code I showed you is very similar, or the initial Pulumi example I showed you is no more simpler than the Terraform example I showed you, and I would completely agree with you. So I want to talk about a real scenario here that I work with. So I have a client who has to deploy a number of websites, web apps, and APIs, and they put an application gateway in front of it. So the gateway acts as predominantly a layer 7 load balancer and also as a web application firewall. And we also have a database. So this client deploys this application in different environments, so prod, staging, but they also deploy for different clients. Sometimes they have to deploy a highly available version of this application. And in that situation, what we have to do is we have to additionally create a traffic manager, which is now the entry point, if you like, into the application. And that traffic manager will route people to a specific region. So in this example, we're setting up as a HA, so highly available, active configuration. So depending on where the user is, they may get sent to either the primary or the secondary region. The reason we're doing this is, one, the users will get better performance, but also if we have an outage on one of the regions, we will fail over to the secondary region. So another thing we have to do here is we have to ensure that the database is geo-replicated and that we've set up a SQL Server failover group. So the failover group specifically is designed that if the data center is offline, it will automatically fail the database connections over to the secondary region. So let's have a think about the steps we need to do to get this to work, and then we think about how we would have done this using the templating approach. So first of all, we need to provision an app service plan, and then provision any number of web apps. So with this client, they sometimes have a variable number of web apps they have to deploy. We then provision the application gateway. Now, if you've ever had to provision the application gateway, you'll know that doing it in the portal is an absolute pain, and doing it with templates is also quite challenging because there are a large number of sub-resources you have to specify and implement. One of the challenging bits with it is you have to ensure that each web app is configured as a route through the application gateway. So if you do add a new website, you need to ensure that you update the application gateway to also have a route to that backend website. You also have to configure SSL certificates, security headers, and health checks. So the application gateway template becomes extremely large and extremely unwieldy. You also have to configure the SQL Server database, and you have to capture the details of that because you'll need that later. Now, if we look at the multi-region deployment, we do everything we do in a single region, but now we need to also capture the gateway addresses. We need to add SQL geo-replication. We need to configure the failover group, and then we need to configure the traffic manager to point to those application gateways. So there's a lot of things going on here. There's a lot of conditional logic, there's a lot of loops. So I'm sure you're dying to see the code for this. Sorry to disappoint you. At the moment, I can't show you the code for this. The code is currently specific to my client, and I am going to turn it into an example and submit it to the examples repo. But suffice it to say that what I'll talk about in the next couple of slides is the reason why I looked at using Pulumi. So the clients I work with are often small teams. They don't have dedicated people whose job it is to manage the infrastructure. So these people are not spending their day in, day out, looking at Terraform or ARM templates. What I showed you just now to do in a Terraform and an ARM template is non-trivial. And worse than that, once you've created it, if you need to add an additional route into it, you have to modify multiple places in the template. You often end up having multiple templates and you have to coordinate them, and sometimes you just copy chunks of code because there's no other way. The other challenge here is that the team, their primary job is to write code, and they may be using C#, and in this case they are, and some front-end code. And now if they want to be responsible citizens managing the infrastructure, using the templating and everything else, they need to understand the cloud platform, and they need to understand the templating language. So of course what most people do is they'll just use the portal, and every time they need to do it again, they find that it's just going to be quicker, as painful as it is just to use the portal again, than it is to create the scripts. Because let's be honest, when you create those scripts, it takes a number of iterations to get them right. If anybody can get the ARM template, a complex one like that, working first time around, you deserve a gold star, because I certainly can't do it. So when I saw that, and I recognized that I was going to potentially leave this client with some really complex templates, and I was concerned about that, and thankfully Pulumi came along just at the right time. So I knew that this team was a .NET team, but of course they didn't have to be. You have TypeScript, you have Go, you have Python. So I knew that the team, as a general team, would be able to recognize the code. Now they're not necessarily going to understand the specific parameters of storage accounts and web servers, but that's a problem every team was going to have to understand anyway. If we can get away from the noise of the syntax, the weird syntax and everything else, and we're looking at loops and if blocks that they're very comfortable with, they can then hopefully get their heads around what's going on with the rest of the syntax. And as I said, if you're a big team and you want to have lots of people managing resources, then you do need to pay for that. But with the smaller teams I work with, we've been able to get away with without paying anything to Pulumi. So let's have a look at some other things and some other elements. And of course, I'll just remind everyone that, again, do feel free to ask questions at Slido. The details are at the bottom of every slide. So one of the nice things with Pulumi is, and again, you can do this with the other platforms, you can create some reusable components. So within Pulumi, there's a stack, and a stack is essentially a group of resources that can be deployed together. And often stacks are used to deploy the same set of resources to different environments, whether this is dev, staging, production, or whether this is a multi-tenanted application and you're deploying individual resources to different tenants. You can create components, package them into a NuGet file, and then share them with other people in your organization. So put them under a private registry and share them that way. Put them on a public registry if you're happy to share resources. And the nice thing with this is you can now compose more complex applications by reusing these stacks you've created. And you can ensure that everyone gets consistent configurations. Now, one interesting challenge that can crop up with this is there's a tendency for some teams or some people to create an abstraction on top of Pulumi. So create an entirely new abstraction that's deriving from the Pulumi code because they want to restrict access to certain properties. You know, for example, they might want to ensure that certain features are never ever enabled by somebody. So they create an abstraction on top of the Pulumi code to hide that particular feature. And while that's entirely doable, one of the challenges you'll face by doing that is you are creating a whole heap of work for yourself when the Pulumi code and the underlying code moves forward. And it's worth mentioning at this point that the Pulumi code and Pulumi service and everything else has been iterating very quickly. It's been fantastic to see there's been new versions updated on a regular basis, several times a week sometimes. So instead of doing that, there's a relatively new feature in Pulumi called policy as code. This allows you to create policies which can then intercept the Pulumi deployments and validate that what's being created is acceptable to you or not. So in the example before where you want to disable a feature, rather than necessarily doing it that way, you can set a default value, for example, that sets it to be off. You can use a policy which prevents somebody from ever switching it on. The advantage of doing it this way is that you're not creating a whole another layer of abstraction around the Pulumi code. And remember, that is also an abstraction on top of other providers and other things. Ultimately, it's an abstraction on top of the cloud provider. And also, what often happens when you create these abstractions is you will find a legitimate reason to use feature X that you disabled, and you have to create yet another abstraction, which then does enable that feature and maybe disable something else. And you'll get yourself in a mess. So the policy as code is a really powerful concept, and I'm really excited to see the support for that. I don't believe it currently has the .NET Core support, or certainly there's not many examples in the documentation, but I'll be looking at that. So this all sounds really great, but you've got a whole heap of existing resources, and you're thinking, well, what do I do? Luckily, you've actually got quite a flexible approach to this. So you have broadly three options. What you can do is you can leave your existing resources exactly as they are, and let them coexist alongside Pulumi. And Pulumi won't interfere with them. What you can also do is adopt existing resources. Now, this doesn't generate the .NET code for you, unfortunately, but what it does let you do is essentially reference that resource and then use it in some of the other code examples and let Pulumi take over the kind of lifetime of that resource. Then the final option is you either rewrite or you generate your Pulumi code if you are using something like Terraform. So there's a tool that generates Pulumi code from Terraform, and you can have a look at that. Now, I don't think I've done this topic justice. There was a guide published literally a couple of days ago, which is fantastic, and I'd recommend having a look at that if you're looking at adopting this. So hopefully I've shown you that I think there's quite a few pros here. So using Pulumi lets you use the languages you're familiar with, and that's really powerful for teams, and especially for teams who don't spend the day dealing with ARM and Terraform. Because you have the power of modern languages, as long as they have SDKs that run in the same language, you can build them into the same pipeline, into the same lifecycle management, and it's all integrated. I think it's quite easy to get started with Pulumi as well, because again, I'm not having to learn the syntax. All I'm focusing on is what's the parameters I need for a storage account, what's the parameters I need for a database. And as I said, it's free and open source, and the only component you don't have access to is this Pulumi console, but it doesn't in any way hamper you from using Pulumi. There isn't a bunch of features which are disabled because you haven't paid for them. So everything is fantastic, obviously unicorns and rainbows. No, there are some drawbacks. So there's fewer platforms compared to Terraform. Now, of course, if your platform is supported, then hey, that's not a problem. Much like Terraform, there is a lag between the release of a feature and support for it in Pulumi. And the Azure provider, and in fact, I think some of the other providers as well, they are actually using the Terraform provider behind the scenes. And I do want to take a moment to really call this out, because I don't want this talk to be Terraform is terrible and Pulumi is fantastic, because Pulumi, the .NET core support in Pulumi wouldn't exist if it wasn't for all the amazing work that the Terraform team do. And because it's open source, Pulumi have been able to use it. So a big shout out there to the Terraform team. And again, you still need to learn and discover the cloud provider's kind of resource API. You need to figure out what parameters they want for a storage account. And again, that's not a Pulumi specific problem, but I just thought I'd mention it. I touched on it earlier, but of course, when you're writing C# code, you have syntax checking and you have a compiler. So if you try and reference a resource that doesn't exist, or more likely, if you make a typo and you don't type the correct name, you'll get a compile error, which is fantastic. So you'll catch a lot more errors much, much sooner. So your loop, your control loop, your feedback loop rather, is much, much smaller. But there are still some errors that won't crop up until you try and actually deploy the code with Pulumi up. Now, this isn't necessarily a problem with Pulumi. It's not their fault. It's usually because the cloud provider's API doesn't surface this option or doesn't surface this validation logic in any way, and you only discover the problem once you try and actually deploy the resource. It's also possible to get Pulumi into a bit of a bad state. The way I've done it quite often is by cancelling a deployment midway. And what usually happens here is the call to the cloud provider has already been made. The cloud provider is busy provisioning the resource, and obviously everything's happening asynchronously. And now I cancel the Pulumi up command. Pulumi's now got in a bit of a mixed state. It doesn't quite understand what state the cloud provider's in, what state it's in. So they very clearly warn you not to do this. But when you're doing a dev or a very kind of proof of concept deployment, it's just a quicker way sometimes to stop, fix your mistake, and start again. And when it does go wrong, there are ways of recovering that. So at this point, when you're looking at me using C# code and .NET, you're probably familiar with some of the SDKs that are available. So there's an Azure .NET SDK. So you might be thinking, well, why don't I use the Azure .NET SDK? Why do I need to use this third-party tool? Fundamentally, what most of these SDKs do is they're abstracting a REST call behind the scenes. Most of the time, what you're actually doing is issuing imperative REST commands to provision resources. So you're not giving them a desired state. you are issuing step by step what you want to create. They're not necessarily idempotent. So what might be happening is you may issue the command twice and you'll get two sets of resources. And also because they're imperative and because they are not tracking the current state, they're not desired state, you don't know what your current state is when you are making a change. You can only really reason about the new state you're making. Alongside this is another class of tools which generally take a general purpose language and turn it into the templating language of the cloud provider. So AWS has this CDK, and again, it looks fantastic because you're using C# code and everything's wonderful. Ultimately, it generates CloudFormation templates behind the scenes. If you're on AWS, fantastic, that might be the perfect option for you. But of course, it only works on AWS. Another option is Farmer, which uses F# code, and this generates ARM templates. And again, both of these options, if you have existing deployment pipelines and mechanisms that deploy templates, then these can slot into that very nicely, and they're a perfectly valid option. Incidentally, the .NET support does include F# if you are an F# folk, and I know there's quite a few out there. You can use F# to use it with Pulumi as well. So the way I like to think of this, and I promise you this is slightly tongue-in-cheek, but when I look at the evolution of this cloud provisioning, we start with the portals, kind of move up to this templating, and we come along to Terraform, and then eventually we're now evolved to using Pulumi. If you want to learn more, the examples I showed, or the example I showed you is on the GitHub there. I will add the multi-region example on there as soon as I've done it and checked it with my client. The Slack channel for Pulumi is fantastic. I have to say massive shout out to the folks on the Slack channel. They've answered questions within minutes of me posting them. They've fixed bugs the next day, and they've helped me figure out some of the more quirky syntax within Pulumi. So thank you so much for them. It really made my life a lot easier. And I have blogged at least one example. That storage account example I've blogged in a little bit more detail on my blog, and I'll probably be adding more examples as we go along. So with that, I'll say thank you very much. My contact details are here, and I'll leave that slide up. And again, if you've got questions, please do use the Slido link. So you can join at slido.com, and it's Y860 for the code. I can stay here for a couple of minutes and see if any questions pop up. If not, we can wrap up, and if you've got any questions I don't get to, then feel free to ping me an email or tweet or DM.